Okay, so we first need to make sure everyone know how to can run Java and blueJ on your computer. So there's a tutorial on Blackboard. Oops, I guess you have to download it and then see it. Okay, install Java JDK and blueJ. Usually, if you I'm not sure whether this is updated or not. Let me also Google, see what's the Java JDK most recent version. Is it AU111? Still AU111? Let me see. Java JDK. AU121 now, so it's not 111 now. It's AU121. Okay, so you need to install the one. Well, for the Mac, you install this JDK AU121. Windows. What's the difference between x6486? I'm not sure actually. If I just take a guess, x86 is the classical Intel version. x64 should be 64-bit version. By why it's named that way, I'm not sure. You need to accept a license, and then you can download. If you also have a Linux version, you can download it. So Linux, apparently there are also different versions now. So x86, x64. I guess that's the convention now. The Linux also goes this way. x86 must be the classical Intel version. 64 maybe 64 bits. ARM, that's the new mobile chip. Mobile CPU, it looks like Apple trying to move that, and Linux also is supporting that. So after you download the JDK, and then you can okay, you can test it. You have to install Java and then blueJ. The order cannot be reversed. Then you can install blueJ. blueJ is actually, let me see if I just Google blueJ. If I what? blueJ is also a bird, so sometimes. Well, if you add Java, you definitely for sure that's the one blueJ. If I just Google blueJ, but I'm using my profile, so it's probably no. I'm looking for the Java blueJ. Yeah. Okay. Yeah. Maybe Google is smart enough to know you are computer science. You are in the computer science class. So if you don't find the blueJ by default, add blueJ Java. And so we want to make sure everybody has installed the Java JDK, and then install blueJ and run People already have blueJ. But just wait. Yeah. It's actually much lightweight. More lightweight. 问题下，告诉我们的有些就是在广告的剩下只能对哇，你快点。Yeah. Okay, good. Oh, you're okay. I use which one you have? Java? What can you call trouble with the I think I call it because these values seem to be just maybe it's in references.
Scroll down to that. Yeah.
Well, even one is not made, huh? Okay, so hopefully most of you reached this step. You have a blueJ somewhere on your computer. So this is on my computer. I just put it on a desktop. In fact, if you actually come up with just this building alone software, standalone software, and then there are example folders. So if I click on the one on the example blueJ, I'm going to click on the hello blueJ. This icon, that's a project file. If I click other, that's a text file, that's a Java file. It may or may not associate with blueJ, so I'm not sure. But I'm going to click on this blueJ file. And then it's associated with blueJ, it open up a blueJ. So that's the hello world example. If you want to make test whether your blueJ and Java are working or not, right click on this. Right click on this hello icon. You will see a few options. New hello, that's for a new object. Void main, that's a method inside of the hello. And then there's the option to compile. I'm going to choose compile, see whether it runs or not. I say compiling, done. Okay, so it's actually can look for the Java compiler. And how do I run this? I right click on this again, and then I choose run the main method. And then, well, the main method asks you for argument, and this hello world doesn't take any argument, so I just click OK, and then it runs say hello world. But if I want to check what's in that, you can double click on the hello box, then it pop up. So this editor window has two options. Right now, if I look on the right hand side, maybe I can highlight it. Hold on, let me turn on my highlighter. Okay, so if I okay, So if I turn on my highlighted, oops, sorry. You see on my right-hand side, it is something say source code. And if I click that, it actually also says document. So that's a Java doc. But right now we can ignore it. Just look for the source code. And that's actually a building blueJ hello world example. It's a bit more complicated than we needed, but and it actually has a class. So Java is something called object-oriented programming language. So everything has start with class, and then you have to for every class there will be building variables and method. And in this simple example, it has two methods: public void go or public static void main. This void go is a bit more complicated. We can actually just delete that one. We can just use this main. We can just remove everything here, and we just say system.out.print quote hello UTC, let's say, and everything has to be closed with a semicolon if it's a full to be grammatically correct. So close out with a semicolon. That's it. I mean, class hello's public static void main, this should be enough. So if I click compile again, class compile, no syntax error at the bottom. Oops. At the bottom you will see no no syntax error. So it's compiled correctly. But how do I run this? How do I run this again? Right click on my hello box. Right click on that, and then I pick the main method. That's the main method to run it. Okay, there's no argument passed to the main code. Click OK. Hello UTC. Now that's the output now. So, okay, so that's the blueJ. But let's go back to the textbook version. So maybe I'll wait a minute, make sure everybody has know how to run blueJ now. Are we okay with all the blueJ thing? Yes. Yes. You have to open the object, the project. So, yeah, it's inside of blueJ, but you already have the blueJ. You already have the blueJ. Start with. Okay. Yes. It's done. It's done. There's nothing. There's no error. And then you just that's the read from. Okay, so for those who have trouble to find a blueJ project, you can just start write your first Java code. So, okay, so I'm going to start. I'm going to start a new project myself. What name should we call it? Hi UTC. How about that? Great, and then I can close my other one. So apparently, blueJ always had to a project open. If I close the first project, no project open, the blueJ just closed. So you have to always keep one active project. If you want to start a new project, start a new one, then close the old one. Okay, so then I'm going to start a new class. So Java is a project object-oriented, something called OOP language. So everything has to start with a new class. There, class type. Going to start with just by default class. What name should I call it now? Pick a name.
First.
What?
First.
First. Okay. First. Our first Java code. All right. So, and then I want to actually look at the Java source code. How do I do that? Excellent. Double click on this. It actually pop up with the editor window. And make sure it's in the source code. One time I actually went to the documentation and then I found out that nothing there. Make sure this is the source code. Right. So in the source code, you will see this is so blueJ already gave you some skeleton things. So you see this the \* those are comment. So those are comment. This red or purple public, that's a keyword. Class is a keyword. First, that's the name I gave it to the class. And inside private, that's a keyword. So public is basically, we can see. Private is something inside of a class. It's almost like a box. So everything I cannot see inside is private thing. Everything I can see from outside, let's say there's an interface here, that will be a public one. So that's the API, or we often call it, a document. We can access it through those kind of public, either method or variable or interface. We can actually use it to asking this back or magic box do something. That's public. Everything inside I cannot see is private. So, all right. And there's a constructor. We're going to ignore that for now. We don't need a. And then there's a public method. You can't. Those common area you can type anything like. So anything like doesn't matter. But it's usually something meaningful. You explain things you want to do and what it means. So, well, I guess if you follow this, we'll change this author to my name and the version. This version, this problem is. It's an interesting thing. What version do you think I should put it here? The software usually starts with something like a 0.0. I often call it 0.01. If you are really not confident 0.01, it really doesn't matter. Yeah, 0.01. If you include the 0.02, if it becomes version 1, that's actually a major milestone. If there's a software version 1, usually it's a quite important thing. If you think about Microsoft has been doing for so many decades, it still had a Windows 10, right? So, but in between there are so many little things, right? Okay, so I'm going to just call it version 0.01. Write description of class here. What class? First Java class in cpsc1100 for 2017. Okay, how about that? And we don't actually need a variable here. All we need just to print out some grading. So it turns out by design, the Java need to have something called main. Sorry, how do I distinguish this with this? Is it main? Anyhow, but what I'm trying to say, every program has this main method. It turns out main usually stands for menu. Apparently, most of the programming is actually studied by males, I guess. So there's a lot of gender insensitive keyword there. Anyhow, so this main program actually can trace all the way back to C++, and Java basically inherits the paradigm. So every standalone Java program has this main method. But this main method basically is the starting point for everything. So this has to be main. And usually it doesn't output something. It's also something called static. What this static means is basically something allocated in the memory. It doesn't change in the runtime. Okay, so but the main is going to have some argument passing to the program. So we're going to have something called string. Notice string I use a capital, and by public I use a lowercase. So Java is case sensitive. The string is a class. Later on we're going to use. So why I putting this here simply because this method of main need to use the string and argument. That's just by definition. Okay, and that's it. We can put some of our code here. And system.out.print. So why I have to type system.out.print?
System prints out.
Yeah, but why I cannot just write print?
Because it's initializing those classes.
Yeah, because those are basically so it's in a library called system. Inside of the library there will be out. Inside of the out there will be a method print. That's I haven't read the full document, but okay. That's been a long time since I actually writing some useful Java code, but this is still not something useful, but it's a good refresh on my memory. So, okay, let's say our first Java code for cpsc1100 for 2017. Let's put exclamation point there, macro point. Okay. Let's see. So the first compile is basically to check for grammar errors. Oh, I missed something. It actually tells me what's excellent. So yeah, I have been programming in some other languages. Doesn't have this rigorous grammar check, so I'm kind of very light on the semicolon. So some languages you can either put it or not put it, doesn't matter. But Java is a more strict language. If I missed out semicolon, it actually doesn't even compile. So okay, let me compile again. And look at the bottom, say class compiled, no syntax error. Yay, first step. And then we're going to run it, see whether it works or not. So I'm going to close this, and then how do I run this? I right click on the first again and say void main. No parameter input. I click OK. Our first Java code, yes, it runs. So there, that's our first Java code. Oh, have you? And I know some of you seem to be more experienced, but I want to make sure everyone can do this at this thing. Yeah. Okay, so let me put my code. So again, Java is case sensitive. This string has to be the first letter has to be capital. So otherwise, it's not going to call the right. Yeah.
Mine version is
Ah. Not because you didn't choose the name. You are actually asking someone to return the integer. Right. What's that? Oh, you need to Fine. That's because you are trying to access a private variable from right. It's in return. This is the method that we need to That's a mistake. Except this one will do nothing because you are thinking inside of this method and your main program here. You have to sit in front of the yeah, okay. What's missing? Oh, I see. Okay. You need to put there and that's yeah. Okay, it looks like not counting. No. Either you need a new pair of glasses or you have to sit in front. So, okay. Actually, can I make it a little bigger? Maybe I can make it a little bigger. Option. Okay, those who oh, okay. Look, I can change this to 14. Will that make it bigger? Okay, it makes it bigger. Okay. So, all right. So it looks like some of you actually don't know how to type these two square brackets. Unfortunately, there's no clear answer where that two square bracket keyboard keys are, but you just have to know. Actually, that looks like it is standard. It looks like it's always on the upper right. Look at every keyboard I see, it's always on the upper right. Yeah. Okay, it looks like it's part of the standard keyboard version. Always on the upper right. So, okay, so that's our first. Can everyone run this one now? You need to go back to a new. And then you have to keep it at work. Yeah. You have to. That's fine. And then, yeah.
Everything has a kernel.
Fun.
I'm sorry. I'm not there today. I have too much knowledge of computer hardware right now. Okay. A kernel? No, the kernel is with the OS. There's kernel and kernel is OS. Your real art is just OS. But there's programs in that.
Okay, so and then let me see. Maybe I should follow the textbook. Okay, so now we can actually try experiment a little bit. So instead of just system.out print, we can do a bit more things. So this time I'm going to type system. I'm going to change that into 2 lines, Java code, my first Java code there, and then I'm going to type the second one, say, for just to make a difference, I'm going to say again our.
You want to put a space either at the end of the first one or at the beginning of the second one, or else they're just going to be smushed together.
Good point. Yeah. So okay. So why I'm doing this? Well, let's run it. No syntax error. Oh, you see, I'm printing to my previous one. So this is my first printout. Our first Java code, for example, exclamation point, and then I printing again our first Java code. So I basically added on to my previous print without even starting a new line. That's basically what the print is. Right, so I want to actually start with a new line. That will be something called print ln, print with a new line. I don't want to start a second one. I wanted the second print actually on the same sentence. So my second print is still print, but my first print, I changed it to print with ln, print with a new line. So, okay, let's compile and do this one again. Okay, so is it good? Oh, what I should do is before I do this, I should print out an empty space because I want to break out with my previous print. I should print out an empty space. Sorry. If you recall, in Visual Logic, we had a similar problem. We need to print out to make the previous print break. Okay, so let's do this again. Compile. Then I'm going to run it again. Haha, finally it worked. Except I should have. Oh, maybe I should put the second one as again our first Java code for CPM. That's good enough. But what I'm trying to do is actually.
When you do print ln, what it does is it adds an extra line after.
Yeah, after that. So I should actually change the second one to print with a line. If I want to, yeah.
You do /n for a new line.
Very good. That's actually, it's a bit more than that. So I can add that one. In fact, does Java also recognize? So you can actually put some new line like this. If you really want to do this. So that's actually put an extra tab if it's. See what this works on. I'm not sure Java can recognize. Oh, actually, no syntax error. Let's run this one. Oh, it actually does. See, it put a tab over there. So that's /t actually is a tab. So anyhow, you don't actually really need to know those technical details. All you need to know is just write basic Java code. Okay, so those are actually something called regular expression pattern, but it won't be covered in CS1. Okay, so that's print. You want to, maybe I give you a few more minutes, try to print, just test the print line, print out something else.
Yeah, I'm surprised.
Oh.
Yeah.
Okay, I'm actually looking bored. Why don't you act as a TA and help your friend? Okay. No, we don't. Okay. I inherit the syllabus file. Now the TA said we won't have exam. Okay. Excellent. So, okay. Let me see what other example the books have. So basically, this is the book's example. Hello printer system .out printer line hello world. That's the book's example. And then let's try that. Oh, is that the same thing? No. Okay, so the book then asks us to try. That seems to be really. You cannot read it. Preference. Actually, I already says it's system.bold. HTML24. Okay, big enough. So let's try this. This time I could do a little bit algebra, I guess. So, okay, so let's try this. System.out.println 3 plus 4. That should give us 7. Okay, and then system.out.print new line. So there are two ways to add a comment. You see these two backslash. That's also a quick way to add a comment. So I can say this is to add a new line. So there are two ways to add the comment. One is to this backslash star followed by backslash star. You have to always close them. Or another way is just to add this two backslash in the same line. That will also add a comment. Everything here will be a comment. This is basically the same thing in C or C++. Java do the same thing here. Okay, so if we do that, let's compile again. No syntax error. Okay, so print on the 7, right? So if I try to do a little bit of more fancy thing, 3, I would say 3 plus 4 equal. So that works. File save. No, I cannot do that. I have to do it at the other lines. Print 3 plus 4 equal, then 3 plus 4. Okay. All right. Compile. Okay, now no syntax error. Run again. Okay, now it print out 3 plus 4 equals 7. So let me see. This line here print out the 3 plus 4 just as the character here. So 3 plus 4, that's what the print out 3 plus 4. And the 7 is evaluated in the next line. This plus 4 print out this 7 there. Okay. And the first one print out the plus 4 with this the sentences. Oh, this actually screen printing is useful in some ways. Although it's I cannot adjust the width of the print. Okay, so that's question so far, or are we going too fast or too slow? Everybody on the same page? All right, so okay, let's look at the book's other example. Okay, so the book provides us a few example how the Java, when you type something wrong, like when I missed the semicolon, it gave me a compiling error. There are some other example of errors here. So this is first error. So what do you think wrong here? Yeah, basically, apparently, when someone typed this, it missed out the T, system.o. so that to be that doesn't even compile. So second one, error 2, Java. Okay, what's the mistake this time? public, this program doesn't do what it should.
Is the space between string and brackets?
I'm not sure. Sorry, let me check the book, see what's the error here. Let me copy paste one into my code, run it, because I don't see why this thing is wrong here.
It should run.
Yeah. Okay, so I just copy paste it here, then compile. No syntax error. I say hello. This is weird. Maybe the example is meaning to say something else. What?
It doesn't say world, it says word.
Oh, I see. Okay, that's what it's like. So many people are looking. I see. Okay. So this one say hello world and there's no L. Okay. Yeah, I was thinking of something else more complicated. Okay, this is a good one. All right, that's why it's a mistake. Okay. Okay, let's look at error 3. Oh, okay. You can try this. I mean, we don't have to. This is computer science. In many things, is practical skill. So let's just system.print out the lines. Let's print out this. I'm going to say print 1 divided by 0 equal, and then I'm going to say system.out.print 1 divided by 0. Okay, so that's what the first one tells people what I'm trying to do. The second one will print. Okay, the no syntax error compiled. But why the computer doesn't check for this kind of error is another question, though. Okay, so Java language arithmetic exception division by 0. So it actually tells me where that mistake occurred. It occurred at the first, as my class first. And inside of my first class, there's the method called main. That's my method main here. And this is the Java running error is at line 20, looks like. Is this line 20? How do I see the line number here? Who knows in blueJ, how do I see the line number? Option, can I show the line number?
You go to find, or tools, you go to find, or it says go to line. And you can type in what's on tools.
In tools, there's a find.
Go to line.
Oh, go to line 20, and then it will show. I see. That's a good idea. Okay, it is on, but there must be a way to show actually the line 20. Okay, but at least now we know line 20 is there. So thank you.
Oh, it's a little red line inside that shows you what line it is.
This?
Yeah.
How do I see?
Just pop it double line. Like it's type in do go to line and then do 19, and you'll see a line, a red line published of that.
Let me see.
So I did the line. So I did 20 line.
I see.
So I'll do 20. That's also conscious.
Oh, I see. Yeah, it also pop up, but I was actually trying to see whether you can label a line 19, line 20 on the side. I'm not sure. Yeah. I was hoping in the options it has display line numbers here, right here. Okay. Excellent. Now it display. Okay. 20. So that's line 20. So in the option there's a display line number right here. So yeah, display line numbers. So all right. Is that arrow 3? Okay, it looks like those are all the sample code chapter 1 gave us. And maybe I should also go over some of the books slides. Just to, well, there are some basic difference between Visual Logic and Java. Visual Logic, in a way, is a flow chart. Java is actually a language. So in an ideal world, when we try to start to write a Java program, we should have a flow chart written somewhere. And in fact, some of the best program I know, they actually started work with paper and pencil. They would like spend days, even weeks, work out what they want to do on pieces of paper, literally. Then actually start to work. And this is also because once you start writing code, sometimes you lose the big picture. If you don't have the big picture, sometimes when you get so much detail, it's very easy to lose the big picture. I mean, there are some other things like IDE. You don't have to use blueJ, even though for this class I give you blueJ, but there are many other things like your voluntary or involuntary TA use something called Eclipse. Or in fact, the book comes with NetBeans. Actually, the book comes with Eclipse. Sorry, the book comes with Eclipse. And we use blueJ simply because it's easy to use. Or it's a lightweight. It's actually even if you work on a coding computer, you can quickly download and it still runs. But other software, Eclipse, NetBeans, you need something of configuration, local configuration, so it's a bit cumbersome. Although it offers more features. So, you can look at the rest of it, why some other things. So there will be CPU, storage on the computer, peripherals, networks. Right now, yeah, it's actually incredible, the CPU, little things, but that's really the main part of the computer. I'm not even sure which CPU this one is. So. And the book was published in 2014. So that must be a very old CPU anyway. So, right. Hard disk. Nowadays, the hard disk also look quite different. And this look like still a spin disk hard disk. Nowadays, there are more faster hard disk. The cost for this kind of spin disk hard disk is actually very slow. I'm actually not sure what the solid state disk work, but it looks almost like an order of magnitude faster than the spin disk going to work. So peripheral, I mean, most of you are already using the computer, so in a way, you're probably familiar with those. And there are something called the Internet of Things nowadays. So there are CPUs almost everywhere. In fact, every car nowadays, every car coming out of the assembly line, people say there'll be I don't know, even hundreds of chips or something there. In fact, the FBI can even follow your behavior if they check the CPU record on your car. So, which is really a question. So there's like there's one way to check the traffic. This is actually a real story in Chattanooga. There are many startups in Chattanooga. They are testing how people's driving behavior. How do they testing it? Because most people, when they drive in the car, they often turn the Bluetooth on and listen to music or radio, right? So they basically check the Bluetooth signal in all those driving vehicles on the street and see what people are actually doing inside of the car. I mean, basically, the inside of your phone is basically a computer, and it does many things in a kind of unsecure way. So let's say that I'm also turn my phone's Bluetooth on when I drove. So yeah. Anyhow. So this actually, the Java language is unique in a way. It actually doesn't run directly on the CPU. It actually runs through something called virtual machine. The way the philosophy of designing Java is actually an interesting story, if I recall it correctly. Basically, someone working a company, we had to deal with so many different versions of a platform. Like in old days, the Apple PC, phone. If it's compiled software, every software had to be compiled specifically for this CPU. But so, from a tech support point of view, they basically write one code, but they had to customize for every possible hardware are selling on the street. So it became a nightmare for tech support to actually support all these different platforms. And so this one guy is so fed up that he wants to quit his job. And is Java started by Sun or I forgot. Anyhow, the company offered him gave him a counter offer before he leave it. They gave him a counter offer. So what do you really want to do? And he said he wants to write a language which can overcome this platform-specific barrier. And the way he come out is something called, I forgot why he called, there's a story why he chose the name Java.
I think he like made it in a coffee shop or something.
Maybe, yeah. But the key code of Java seems to be just written in a few weeks with a few people, like literally bury something in a place and probably plus some cans of beer. Literally a few people bury themselves and in a few weeks come out with this Java language. The whole idea is to use a virtual machine run on different platform, but the actual software is the same, run on every machine. Because through the virtual machine, almost like an interpreter, right? Like if I don't know Spanish, I go to Spain, I need an interpreter. And if I go to what other country? Germany. I cannot speak German, but I need a German interpreter. But that it basically almost like, I mean, I still the same. I don't speak different language, but when I go to a different place, there is an interpreter there to help me to survive. That's the basic idea of Java. The Java language is the same. Once you write a Java program, you don't have to change it for every platform. But every platform has a different virtual machine there. It's going to run it. That's the basic idea of Java. So it's something you write it once, runs everywhere. Now there's a drawback of that. What's the drawback of that? You have to run through extra layers, so it's not fast enough. So it's lightweighted, it runs everywhere, but there's sometimes the speed is not very fast. So if you tailor to a specific CPU, you know how it works, you can make it run faster than Java sometimes. Actually, oftentimes. Okay. But nowadays, very often, because the CPU speed is so fast, from the consumer point of view, sometimes it really doesn't matter too much, right? So if you can complete a task in say 0.1 second versus 0.11 second, 0.01 second, it probably doesn't feel the consumer probably cannot see the difference. So as long your hardware is fast enough, Java is okay, right? So except is in some other mission critical things, the speed is really matter. Like if you want to execute a stock put or call order before someone else does, you don't want to use Java to do that. So sometimes if the time is indeed the money, you don't want to use Java to do that. You want to really write a low level code to do that. Okay, so from this one, like this is basically applets runs everywhere for people take chemistry class to look at the chemical structure. I mean, if it's 1 over 100 seconds slower, probably no one noticed. So yeah, okay. So and it's also used for like right now. I mean, so many Android phones are mostly Java based. So this write once runs everywhere idea certainly is a great idea. So okay, there are many other things I really don't want to read it to you, and you probably also know everyone now have a laptop are working on it. So okay, so I don't think I'm going to go over this slide again since we already worked on the exercise. Okay, so tomorrow we will have a lab and hopefully we go through more exercise. And I still encourage you to bring your own laptop because you are more comfortable with your own laptop, right? Even though we have a lab computer. So okay, that's all I have. See you tomorrow. Yeah.